everybody. Today we're going to learn about Chapter 3, Lines, Angles, and Shapes. Let's start. Here are the key words: line, parallel, angle, perpendicular, acute, right, obtuse, reflex, vertically opposite, corresponding, alternate, co-interior, triangle, quadrilateral, polygon, and circle. In this chapter, you will learn how to use the correct terms to talk about points, lines, angles, and shapes. Classify, measure, and construct angles. Calculate unknown angles using angle relationships. Talk about the properties of triangles, quadrilaterals, circles, and polygons. Use instruments to construct triangles. And calculate unknown angles in irregular polygons. So in this photo, white light is bent by a prism and separated into the different colors of the spectrum. When scientists study the properties of light, they use the mathematics of lines and angles. Geometry is one of the oldest known areas of mathematics. Farmers in ancient Egypt knew about lines and angles, and they used them to mark out fields after floods. Builders in Egypt and Mesopotamia used knowledge of angles and shapes to build huge temples and pyramids. Today, geometry is used in construction, surveying, and architecture to plan and build roads, bridges, houses, and office blocks. We also use lines and angles to find our way on maps and in the software of GPS devices. Artists use them to get the correct perspective in drawings. Opticians use them to make spectacle lenses, and even snooker players use them to work out how to hit the ball. Lesson 3.1, Lines and Angles. Mathematicians use specific terms and definitions to talk about geometrical figures. You are expected to know what the terms mean, and you should be able to use them correctly in your own work. Terms used to talk about lines and angles. So here are the terms, what it means, and the examples. The term point. A term point. The meaning of it is a point is shown on paper using a dot or a cross. Most often you will use the word point to talk about where two lines meet. You will also talk about points on a grid, positions, and name these using ordered pairs of coordinates, X, Y. Points are usually named using capital letters. An example of this is the point B, with the X coordinate of 2 and the Y coordinate of 3. Line. A line is a straight, one-dimensional figure that extends to infinity in both directions. Normally, though, the word line is used to talk about the shortest distance between 2 points. Lines are named using starting point and end point letters. An example of it is the line between the 2 points A and B, and this is called the line AB. Parallel. A pair of lines that are the same distance apart or all along their length are parallel. This symbol is used for parallel lines, like AB is parallel to CD. Lines that are parallel are marked on diagrams with arrows. An example of that is that there are two lines, line AB and line CD. And here we can see that the two lines are parallel to each other. Angle. When two lines meet at a point, they form an angle. The meeting point is called the vertex of the angle, and the two lines are called the arms of the angle. Angles are named using three letters: the letter at one end of one arm, the letter at the vertex, and the letter at the end of the other arm. The letter in the middle of an angle name always indicates the vertex. An example of that is angle ABC, with the vertex being B, being the point B, and the arms being the point A and C. Perpendicular. When two lines meet at right angles, they are perpendicular to each other. This symbol is used to show that lines are perpendicular. Like N is perpendicular to PQ, and this is an example of it. As you can see here, the angle M and Q and the angle M and P are both 90 degrees right angles. So we can see here that the line MN is perpendicular to the line PQ. Acute angle. An acute angle is less than 0 degrees, but more than 90 degrees. Here are some acute angles. Right angle. A right angle is an angle of exactly 90 degrees. A square in the corner is usually used to represent 90 degrees. A right angle is formed between perpendicular lines, like this. Obtuse angle. An obtuse angle is more than 90 degrees but less than 180 degrees. And here are two obtuse angles. Straight angle. A straight angle is an angle of 180 degrees. A line is considered to be a straight angle. And here is a straight angle, or you could say the line MO. Reflex angle. A reflex angle is an angle that is more than 180 degrees, but less than 360 degrees. And here are two reflex angles. Revolution. A revolution is a complete turn, an angle of exactly 360 degrees. And here's a complete turn, or a revolution, around the point O. Measuring and drawing angles. The size of an angle is the amount of turn from one arm of the angle to the other. Angle sizes are measured in degrees from 0 to 360 using a protractor. A 180-degree protractor has two scales. You need to choose the correct one when you measure an angle. So there's two scales: the clockwise scale, going from left to right, and the anti-clockwise scale, going from right to left. Measuring angles that are more than 180 degrees. So, put the center of the protractor on the vertex of the angle. Align the baseline till it lies on top of one arm of the angle. Use the scale that starts with 0 to read off the size of the angle. Move around the scale to the point where it crosses the other arm of the angle. Work example 1. Measure angles ABC and PQR. So place the center of the protractor at B and align the baseline with ellipsis on arm BC. Extend arm BA so that it reaches past the scale. Read the inner scale. Angle ABC equals 50 degrees. And you just do the same with the other angle PQR. Measuring angles that are more than 180 degrees. Here are two different methods for measuring a reflex angle with a 180 degrees protractor. You should use the method that you find easier to use. Suppose you had to measure the angle ABC. Method 1. Extend one arm of the angle to form a straight line, 180 degree angle, and then measure the extra bit to 180 degrees to get the total size. Use the protractor to measure the other piece of the angle DBC, marked X. Add this to 180 degrees to find angle ABC. 180 degrees plus 130 degrees equals 310 degrees. So therefore angle ABC equals 310 degrees. Method 2. Measure the inner or non-reflex angle and subtract it from 360 to get the size of the reflex angle. You can see that the angle ABC is almost 360 degrees. Measure the size of the angle that is less than 180 degrees, non-reflex, and subtract from 360 degrees. So 360 degrees minus 50 degrees equals 310 degrees. Therefore, angle ABC equals 310 degrees. Exercise 3.1. For each angle listed, state what type of angle it is, acute right or obtuse, estimate its size in degrees, and use a protractor to measure the actual size of each angle to the nearest degree. What is the size of the reflex angle DAB? So each of these angles are BAC, BAD, BAE, CAD, CAF, CAE, DAB, DAE, and DAF. Applying your skills. Question 2. Some protractors, like the one shown on the left, are circular. How is this different from the 180 degrees protractor? Write instructions to teach someone how to use a circular protractor to measure the size of an obtuse angle. How would you measure a reflex angle with a circular protractor? Drawing angles. It is very easy to draw an angle of a given size if you have a ruler, a protractor, and a pencil. Work through this example to remind yourself how to draw angles less than 180 degrees and more than 180 degrees. Work example 2. Draw angle ABC equals 76 degrees and angle XYZ equals 195 degrees. So use a ruler to draw a line to represent one arm of the angle. Make sure the line extends beyond the protractor. Mark the vertex B. Place your protractor on the line with the center at the vertex. Measure the size of the angle you wish to draw and mark a small point. Remove the protractor and use a ruler to draw a line from the vertex to the points. Label the angle correctly. For a reflex angle, draw a line as in A, but mark one arm X, as well as the vertex Y. The arm should extend beyond the vertex to create a 180 degrees angle. Calculate the size of the rest of the angle. 195 minus 180 equals 15 degrees. Measure and mark the 15-degree angle on either side of the 180-degree line. Remove the protractor and use a ruler to draw a line from the vertex to the third point. Label the angle correctly. Exercise 3.2. Use a ruler and a protractor to accurately draw the following angles: 80 degrees, 30 degrees, 135 degrees, 90 degrees, 210 degrees, and 355 degrees. Angle relationships. Make sure you know the following angle facts. Complementary angles. Angles in a right angle add up to 90 degrees. When the sum of two angles is 90 degrees, then those two angles are complementary angles. Supplementary angles. Angles on a straight line add up to 180 degrees. When the sum of two angles is 180 degrees, those two angles are supplementary angles. Angles around a point. Angles at a point make a complete revolution. The sum of the angles at a point is 360 degrees. Vertically opposite angles. When two lines intersect, the two pairs of vertically opposite angles are formed. Vertically opposite angles are equally in size. Using angle relationships to find unknown angles. The relationships between angles can be used to work out the size of unknown angles. Follow these easy steps. Identify the relationship, make an equation, give reasons for statements, and solve the equation to find the unknown value. Work example 3. Find the size of the angle marked X and each of these figures. Give reason. 72 degrees plus X equals 90 degrees. Angle ABC equals 90 degrees. Complementary angles. X equals 90 degrees minus 72 degrees. And X equals 18 degrees. You are told that angle ABC is a right angle. So you know that 72 degrees and X are complementary angles. This means that 72 degrees plus X equals 90 degrees. So you can rearrange to make X the subject. "48 degrees plus 90 degrees plus X equals 180 degrees. Angles on a line. 180 degrees minus 90 degrees equals 48 degrees. X equals 180 degrees minus 90 degrees minus 48 degrees. And X equals 42 degrees. You can see that 48 degrees, the right angle, and X are angles on a straight line. Angles on a straight line add up to 180. So you can rearrange to make X the subject. x equals 30 degrees, vertically opposite angles. You know that when two lines intersect, the resulting vertically opposite angles are equal. X and 30 degrees are vertically opposite, so x equals 30 degrees. Exercise 3.3. In the following diagram, name a pair of complementary angles, a pair of supplementary angles, the complement of angle EBF, a pair of equal angles, the angles on the line DG, a supplement of angle EBC. Question 2. In each diagram, find the value of the angles marked with a letter. Question 3. Find the value of x in each of the following figures. Question 4. Two angles are supplementary. The first angle is twice the size of the second. What are their sizes? Question 5. One of the angles formed when two lines intersect is 127 degrees. What are the sizes of the other three angles? Angles and parallel lines. When two parallel lines are cut by a third line, the transversal, 8 angles are formed. These angles form pairs which are related to each other in specific ways. Corresponding angles with an F shape. When two parallel lines are cut by a transversal, 4 pairs of corresponding angles are formed. Corresponding angles are equal to each other. Alternate angles. Z. When two parallel lines are cut by a transversal, 2 pairs of alternate angles are formed. Alternate angles are equal to each other. Cointerior angles. C shape. When two parallel lines are cut by a transversal, 2 pairs of cointerior angles are formed. Cointerior angles are supplementary. Together they add up to 180 degrees. These angle relationships around parallel lines combined with the other angle relationships from earlier in the chapter are very useful for solving unknown angles in geometry. Work example 4. Find the sides of angles A, B, and C in this figure. Question Exercise 3.4. Question 1. Calculate the size of all angles marked with variables in the following diagram. Give reasons. Question 2. Decide whether AB is parallel to DC in each of these examples. Give a reason for your answer. So, that's the end of this lesson. Make sure to share this video. Thank you and goodbye.